Let's break down what an AKS node pool is and what's actually inside it. In Azure Kubernetes Service, or AKS, your Kubernetes cluster is made of control plane components and worker nodes. A node pool is simply a group of worker nodes that are created and managed together. Think of it like a fleet of identical machines that Kubernetes can schedule pods onto. Why group nodes into pools? Because different workloads often need different kinds of machines. One pool might be small and cost-efficient for lightweight services, another might have more CPU or memory for heavy processing, and another might use GPUs. By separating nodes into pools, you can scale, upgrade, and configure each group independently. Now, what's inside a node pool? First, the most visible part, the nodes themselves. In AKS, each node is an Azure virtual machine, typically created from a VM scale set. All nodes in the same pool share the same VM size, operating system type, and base image version, so they behave consistently. Second, the node configuration and metadata. Each node in the pool has Kubernetes labels and optional taints. Labels are key value tags that help you target workloads, like workload equals frontend or tier equals batch. Taints are a way to repel most pods unless they explicitly tolerate the taint, which is useful for dedicating a pool to a specific workload. Third, the Kubernetes components that run on every node. Each node runs a container runtime, like Containered, and a set of core agents. The kubelet is the key agent. It talks to the Kubernetes API and makes sure the pods assigned to that node are actually running. There are also networking and storage agents that enable pods to communicate and mount volumes. Fourth, networking. A node pool includes networking setup that lets pods get IP addresses and reach other pods and services. Depending on how your cluster is configured, pods may draw IPs from the Azure CNI network, and the nodes will have routing and network rules to support service discovery and traffic flow. Fifth, the disk and file system layout. Every node has an OS disk, plus temporary storage, and optionally attached data disks. Containers use this storage for images, logs, and ephemeral volumes. If your pods need persistent storage, they typically use Kubernetes persistent volumes backed by Azure Managed Disks or Azure Files, which are attached or mounted when needed. Sixth, scaling and lifecycle behavior. Node pools define how many nodes exist at a time, either fixed or with cluster autoscaler enabled. They also define upgrade settings, like how nodes are drained and replaced during a Kubernetes version upgrade. One more important idea: the system node pool versus user node pools. The system pool is intended for critical cluster add-ons and services. User pools are where your application workloads usually go. Keeping these separate helps reliability and makes scaling safer. So the summary is: an AKS node pool is a managed group of worker VMs with shared configuration, running kubelet and node services, wired into cluster networking and storage, and managed together for scaling and upgrades. Once you understand node pools, you can design your cluster to match each